The flowing water in a river is the result of force. Force changes into a state of motion, and that motion changes the entire body of water. It is a vector quantity, and it has both magnitude and direction. In nature, several forces are in action. The driving force and a resistance force are particularly important for a flowing river. They move a mass of water with a particular acceleration. A flowing river moves even larger boulders from one place to another place. So enough force must be exerted over the required distance to move a large piece of boulder. If a river is flowing above a rough surface, it must spend energy, and the potential energy results from its position with respect to some reference level, and the kinetic energy results from its motion as the river flows. So the potential energy of a flowing river will decrease as it moves from mountains to the plains with decreasing elevation above sea levels, but the kinetic energy increases with increasing stream velocity. In the context of river processes, fluxes are very important, and they refer to flow sediment interactions, how the sediments are interacting with the river flows. Large channels are often dominated by sandy bed material, and they have large sand bed forms. Size of the drainage basin will also determine the water supply at a given point along a drainage basin. There is an increase in stream discharge with drainage basin, area of the drainage basin. The channel width will also increase as the river moves more rapidly than the depth of the river from upstream to the downstream. Large rivers split to form delta with accumulated sediments at the end before merging into the sea, and the braided rivers are associated with high energy environments, high sediment loads, and unstable channel banks. So the variable flow regime of a river must be respected. The variable flow regimes act as an overriding factor in shaping the entire habitat, whether it is pool or run or riffle, and they also structure the aquatic habitat or the biota. In general, the more variable flow regimes that mimic natural flow, the better would be the species composition and richness and abundance. And one very important factor is that the groundwater sustains the river flows. Groundwater is our lifeline. It makes our ponds, our wetlands, and rivers flow. We get rains only for a few days. It is the recharge to the aquifers that gradually yields back to the water bodies. And this precious groundwater is nurtured in the floodplains, along the rivers, and in the forests. So just like protected forests and national parks, we need water sanctuaries. We need areas as protected landscapes on both sides of the river for recharging the rainwater. And this is best done naturally, as nature has marked many special recharge areas through thousands of years of natural cycles. And those sites are the best sites for recharge, such as river terrace, floodplains, ponds, and forests. So a natural floodplain improves water quality, it conditions the soil, and it nurtures plants and animals. The water that reaches the rivers and lakes are in a better condition and part of a healthier environment. A good coverage of vegetation acts as a refuge to wildlife, and it also improves the habitats. So protecting water bodies are very important in cities and towns. But also important is the protection of the entire watersheds. We just have to ensure that we don't encroach upon these blue landscapes. One of the very remarkable observations in these days are that the perennial rivers are becoming seasonal rivers, and that is happening due to loss of base flows. The perennial rivers have become seasonal rain-fed rivers, and they have dried up at several places. Many small rivers and springs have dried up and disappeared from our villages, and that had happened during the last 3 decades. Rapid and unscientific land use changes, deforestation, encroachment, rapid urbanization, and excessive water withdrawal, they are creating havoc to our rivers. Many large perennial rivers have become seasonal, and they are called intermittent rivers. Intermittent or seasonal rivers now exceed the length of the entire world's perennial river networks. The proportion of intermittent rivers could even exceed 50% of the global river network. Many rivers in the Satpura, in Vindhya, in Aravallis, and even in peninsular India, they originate from forests. But due to shrinking forest cover, due to stone quarrying, due to open cast mining, and unabated groundwater exploitation, majority of such streams have become seasonal, or they have been completely wiped out. With the drying of a river, dies the habitat that once flourished with this flowing water. Survival of species becomes at stake when the flow recedes and the quality goes down. A river dries when it is fragmented, and when it stops receiving surface water and groundwater, the river is dead. The excessive dewatering of aquifers could spell doom to our rivers. Flows in perennial rivers depend largely on groundwater systems. In fact, groundwater provides base flows to our rivers. If we lose groundwater, we lose the river. While we talk about loss of groundwater tables in few centimeters or few inches per annum, but in reality, it could mean a large scale mass loss for the entire river basin, and that could be in cubic kilometers, not in few inches, and that could be attributed to excessive extraction of groundwater. This can severely dehydrate groundwater dependent ecosystems. So flow variability or hydrologic variation plays a major role in shaping a habitat. So there is a great deal of relationship between flow regimes and a habitat type. Tropical rivers are characterized by distinct flow regimes or cycles which are related to the terrestrial phase or the dry phase or the aquatic phase or the flood phase. The flood phase or the wet phase of a river transports biota of small rivers to the large rivers. The connected vegetated buffer continues to remain robust with overbank flows. Our rivers should be maintained with minimum alterations. They must flow freely in their natural state while maintaining longitudinal, lateral, and vertical connectivity. All the aquatic macroinvertebrates, they have different levels of sensitivity towards the wet phase and the dry phase of a river. And it changes in the water quality. The more sensitive biotic organisms, they will tend to either die or migrate from areas that have bad water quality. So in conclusion, I would like to say that we need to protect our landscapes. the connected landscapes. Often the funds on river rejuvenation are spent on making cosmetic changes such as riverfront projects, which are only detrimental to the health of the river. River cleaning is not river rejuvenation. Many river restoration projects have initiated with minimal scientific context, with quick fix solutions, and that too at the reach scale. And that is happening in a very piecemeal approach. The spatial limitations further inhibit rivers to be restored to natural conditions. Our engineers are not guided by the solid conceptual models of river ecosystem and ecosystem processes. Just like protected forest and national parks, we need water sanctuaries. We need areas as protected landscape for redeeming our fresh water. Thank you so much.